Hey, now we're going to talk about motion. The study of motion is called kinematics. Now, right now, we're not concerned with why things move. We're only concerned with how things move. And we'll start with one-dimensional kinematics, and then eventually we'll go to two-dimensional kinematics. First thing we have to talk about is position. For position, we decide where zero is going to be. In other words, we decide where our starting point is going to be. We decide where we measure from. It might be the door of your house. It might be the starting line on a track meet. But we get to decide that. And for a variable for position, we're going to use x. This is also a scalar quantity. A scalar quantity is something that's defined only by a number. It does not need a direction. We'll contrast that with a vector quantity later. Now, we also have to understand the difference between distance and displacement. Distance is a scalar quantity. Displacement is a vector quantity. Distance is simply how far you've traveled. And for that, we're going to use the letter x like in position. It's simply going to be 3 miles, 500 meters, etc. Now, displacement is how far in a straight line from your starting point to your finish point. So therefore, if this is my starting point up here and this is my ending point, my distance could be any possible way that I go there. For example, I could go this way and just curve all around and all that. The distance would simply be how far I actually travel, where the displacement is going to be a straight line from where you start to where you finish. We also put an arrow on it to indicate direction. So that's going to be displacement. Distance would be all of this. And that would be distance. So for example, your displacement over the next 24 hours. Let's assume 24 hours from today's class. 24 hours from today's class, where are you going to be? Right back here. So your displacement is actually 0, but your distance could be all over the place. Okay, let's look at an example problem. Chewbacca goes out for a walk, and he walks 1,600 meters north and then 200 meters south. What is the displacement covered? In physics, it's a good idea always to draw a sketch of what's going on, roughly to scale. You don't have to draw diagrams or anything like that. So we would do something like this. And that's going to represent our 1,600 meters. We're going to say north is up. So then we turn around. He turns around and walks 200 meters south, like that. His displacement is going to be this distance here. His distance is going to be 1,600 plus 200 meters, 1,800 meters. And we don't worry about direction. Now let's take a look at his displacement. Again, 1,600 meters. This is north, 200 meters south. Now it's a straight line from where he started to where he finished, which is going to be 1,400 meters, and it's pointing north. With displacement, all we worry about is where you start and where you finish. In addition to distance and displacement, there's also some other terms we need to talk about, and one of those is average speed. Average speed is simply the speed over some unit of time. Instantaneous speed is looking at your speedometer. It's what it is right at that second. Average speed is over some period of time. So average speed. Now, for speed, we're going to use v. Why v? Because that's what they used for years. Average speed is nothing, and we're going to use a bar for average. Now, we may not always draw that, but we use that bar for average. Average speed is nothing more than distance divided by t. That's not a t. That's a t. So average speed is nothing more than than distance divided by time. In our system, it's going to be meters per second is the most common one. You may also hear kilometers per hour. You're probably already familiar with miles per hour, but therefore meters per second is the one we're going to use most of the time. So that's kind of our first equation right there. Speed is a scalar quantity. We'll talk about the difference between scalar and vectors more in class. Now, average velocity, on the other hand, average velocity is equal to displacement over time. We're still going to use V, but we generally, in the books, they'll use a darker V, a bolder V. They also can put a vector sign over it to let you know that this is a vector quantity. Direction is important. So now it's going to be displacement over time, which is your change in position divided by time. Delta simply means change. You'll use that a lot in math classes as you go on. So now we're talking about displacement over time. Now, I think this is best understood through an example. So let's go back to our original example. Okay, let's go back to our example problem and let's calculate the average speed of Chewy. Now, Chewy walks 1,600 meters north and then 200 meters south. What is his average speed? Key thing there is speed. Speed is going to equal to x divided by t. We always write our equation in an equation form. To any algebra, you have to do first. Okay, now, next thing we're going to do is we're going to go ahead and put in 1,800 meters divided by 500 seconds. Now, we do the math, we get 3.6. Now, look at your units. Meters divided by seconds. Nothing cancels out, so your units are meters per second. Then put a box around your answer. That's it. Now, let's do the same problem, except now let's calculate the average velocity if he walked it in 500 seconds. So now we're going to say average velocity. Remember, that's a vector quantity, so it might help to remind you to draw a vector sign over the V to let you know that direction is important, is equal to delta x over t. Well, delta x was 1,400 meters north divided by 500 seconds. And if we put that into the old calculator, 1,400 divided by 500, we get 2.8. Now we take a look at the units, nothing cancels out, we have meters per second, and then we tag a north on there, the direction. So he walked 2.8 meters per second to the north direction is his total velocity. Last thing I want to introduce to you, just so you start thinking about it, is acceleration. Acceleration is equal to delta V over t. It's equal to the change in velocity. Now, notice how I said change in velocity, not change in speed, because you can change speed, but you can also change direction and still be accelerating. So both of those will work, whether it's speed or direction. Now, let's take a look at the units, because the units are kind of neat. If a change in speed or a change in velocity is going to be meters per second divided by time, which is second. Now, I almost prefer to keep it that way for a while. Your speed is changing so many meters per second each second, and that's what velocity is. Now, if you reduce meters per second, it reduces down to meters per second squared. Prove that to yourself by going through your old multiplying by the reciprocal. The reciprocal of s is 1 over s. M over s times 1 over s is equal to m over s squared. So quite often, that's the way you'll see it written. But I don't mind if you say meters per second per second. It'll help you actually understand it a little bit better. In this class, we're going to deal with zero acceleration or constant acceleration. Changing accelerations is for another day and another class in graduate school and when you go for a PhD and stuff like that. So I hope this helped. What I want you to do is create a page of notes off this video, explain the difference between distance, displacement, speed, velocity, and in generic terms, what acceleration is. More in class.